two sections go together. So on the quiz that we'll have on Tuesday, it will have the f of g, the g of f, finding the domain, horizontal line test, finding the inverse, are they inverses, all that stuff. And there are questions like that on your unit test. So hopefully it'll be a nice review for when we have to do the unit test. But so I just am going to give you these two functions, which, yes? I'm just going to tell you that these two are inverses, and I'll show you how we can find that out in a minute. But if you graph these two functions, which are pretty simple linear graphs, I just want to show you what happens when you graph a function and its inverse, some things that are true. So this is just good old y equals mx plus b. So if I graph f of x, I have a y-intercept of 2 and a slope of 1. Right? That's f of x. And if I graph g of x, I have a y-intercept of negative 2 and a slope of 1. That's a terrible graph. Well, no. The perpendicular lines have opposite reciprocal slopes. But don't you agree if we plug one of those into the other one, it's going to give us x back? I graphed that right? I graphed that right? So here's how you can tell that two functions are inverses. Did the x's and the y switch places, which is kind of weird when it's a simple graph like this. But like this is the point 0, 2. Yes? So if this is on the function, then on the inverse function, better be the point 2, 0. And that's true, right? If you look at this point, this is the point negative 2, 0. Notice that the point 0, negative 2 is on the inverse. They switch places. That's the definition of an inverse, is the x's and the y's switch. So I had a little question on here like, what do you see? We could say x and y switch. These are supposed to be parallel. My line kind of is terrible here at the end. I'm going to try to fix this. Doesn't really be like this line, sort of. Something else to notice, not that you have to know this, but inverses are symmetric about the line y equals x, which is the line that cuts through this graph, like diagonally. Which means with straight lines, when they look like this, they just end up being parallel. But remember what it means to be symmetric. That means if we took f of x and we flipped it over this line, they would match up identically. In geometry, you actually learned about doing symmetry with the line y equals x, and you learned that to do that, you just switch x and y, because that's the definition of an inverse. So some of your homework, they ask you to find the inverse and graph it. They're not going to be crazy terrible graphs, but they could be lines, they could maybe be a square root and a quadratic or something. But if you have to graph them, graph one, and you can just switch the x and the y to graph the other one, okay? So, symmetric with the line y equals x. So I think there's one on your homework that's kind of like this, that kind of threw a weird one there. It says, the graph of f of x is given. So if this is f of x, can you think about what the inverse of that function would look like if we know it means all the x's and y switch, and if we know that means it flips over that line I drew in, that line y equals x? I drew 1 point on there for sure, right? This is my hand-drawn graph. This is the point 2, 0. So do you agree that for sure 0, 2 has to be on that inverse? And then if we take this and we flip it over, right? We're going to take this and flip it this way. How's that going to look? Anybody going to draw that? Anybody feel fancy enough to draw that over? Yeah.
Can I draw one more?
Sure.
So I can like guess, and
Yeah, you can get close, right? And then get close. 5 and a little more than 2, right?
Call it 5, 2. 2, 5, right?
Mm-hmm.
Ish. Well,
Just gets really good at that.
oh, like, 1, 3. Okay.
And then just the same kind of shape there. I think I would count that right. To reflect it?
Yeah, like copy it.
How about this?
Oh, gosh.
The lip. Left, right, up, down. It's kind of weird. It's not...
kind of weird to think about.
Oh, that didn't work. Flip. Go back the other way. Yeah. I could do, I don't know, I could do really weird stuff. But yes, I could clone this, like this, and then I could take it over and I could flip it around like this.
That's pretty close.
And again, he estimated, and so that's why it's a little off, because it wasn't exactly those points. But yeah. But you don't have that cool button on your paper, so, but yeah. And I think there's a couple like that on your homework, so I just want to do that. But here's the big thing that we haven't talked about yet. How do you write the equation for the inverse of a function if you have the function itself? And the big idea is inverses means the x's and the y's switch places. So I wrote these steps out. These are the same steps that I give in Algebra 2, same steps Mr. McClure gives in Algebra 2, because he uses my notes. But when you are finding the inverse, you just want to switch x and y. A lot of times they use f of x instead of y, but remember those mean the same thing. So you can really shorten this up to way less than 4 steps, but if you get stuck, these will always work. Step 1, change this to a y, and then remember, the definition of an inverse is that x and y switch places, so we're going to do that in our equation. Switch x and y, solve back for y, but then instead of leaving y, we're going to call it the inverse of x. So we're going to start with a nice linear equation, and on your homework you have directions just like this that say find the inverse, and then graph them on the same graph. And it's really nice because you can check to see if they reflected in that line. So this is the same as saying y equals 1 minus 3x. So I'm going to switch it, and I'm going to make that x equals 1 minus 3y. And then you just have to be able to solve that back for y. You have to graph it. So for me, when I see a linear equation, when I solve it back for y, I'm going to write it as mx plus b instead of like the big fraction. But to solve for y, I'm just going to subtract 1. And I'm going to get x minus 1 equals negative 3y. And then I'm going to divide everything by negative 3. And again, think about slope here. Like you could leave this as x over negative 3. I'm just going to write it as the fraction. Like I'm going to say negative 1/3 x. And negative 1 divided by negative 3 is positive 1/3. And then instead of leaving it as y, and you can put the y over here, doesn't matter, I'm going to go ahead and say I'm going to write the notation for inverse. So I'm going to say the inverse of f equals that instead of y. And again, you can see how you can kind of shorten those steps. Automatically, you could switch x and y without replacing f of x with y. Definitely, you're going to have to be able to find the inverse of a function. Graphing this, there's a couple ways we could do this. We could just graph both of these. But I think f of x is easier to graph than the inverse because of the fractional point there. So think about if we graphed 1 minus 3x. I'd have a y-intercept of 1, and a slope, if I went down 3, that means I'd go over positive 1. Or you could go up 3 and back 1. I don't know why I make so many points, but remember, if you don't want to actually graph the other one, especially if it's something ugly, you can just switch those points around. So if you wanted to graph the other one, instead of actually going to 1/3 and doing a slope of negative 1/3, which we could do, I could just switch these. So if this is the point 0, 1, I know the inverse has a point 1, 0. This is the point 1, negative 2. I could do negative 2, 1. And this is the point negative 1, 4. I could do 4, negative 1. And that does have me a slope of negative 1/3. And it is reflected about that line when I do it. So I just wanted to remind you that you don't necessarily have to graph both of them when you're doing it. If they make you graph it, it's not going to be a crazy rational function, but it might not be a linear equation either, because we talked about quadratics, we talked about cubics. We should be able to do those. So like look at number 4 really quick. I only have 2 examples left. So. Notice on this one, they tell you the function is x squared plus 9, but then they say where x is greater than or equal to 0. Remember that we talked about yesterday, if you had a quadratic graph, if you had x squared plus 9, that does not pass the horizontal line test. So what they've done is they've said, okay, let's just look at the right side of that quadratic. Let's just look at the positive side. That passes the horizontal line test, so that's what I'm going to find the inverse of. So that's what that means. You're only going to graph values bigger than 0. But to actually find the inverse, that really means nothing. I'm just going to switch x and y. And this is what I mean by you can kind of combine a couple steps. This is y. So is it okay if I just say that becomes x equals y squared plus 9? Right? Like you can skip that step if you don't want to write in y equals x squared plus 9. It's not a big deal. So it's not, I mean, to write it down. But a lot of people just automatically switch it. If you remember that that's what you're supposed to do, you've really done the inverse part. Now it's just solving it back for y. What would I do to solve this back for y? At some point I'm going to have to take the square root because that's how I'm going to get rid of the y squared, but I can't do that until I get that y squared by itself. So what should I do before that? I'm going to subtract 9 first. So I get x minus 9 equals y squared. And then to undo squaring something, I am going to take the square root of both sides. And normally when we take the square root of both sides, we have to do plus or minus. But remember, we only want the positive side. So that's going to tell me that I'm only going to take the positive square root of x minus 9. If for some reason that said x is less than 0, it wouldn't be, well, then I would have the negative out front. All right, so that's making sure that they're functions, that they pass the vertical line test. Again, we could graph both of these by making an XY chart or using what we know about the shapes of the graph. But usually one is a little bit easier to graph together, like this, x squared plus 9. We know that's a quadratic. What does it mean when there's a plus 9 here? What does that mean has happened to my graph? It went up 9. So I can go up, that's why I made this extra tall here. 2, 3, 4, 5, 6, 7, 8, 9, 10. Or even close to there. Remember this part out here now. Because although I know x squared plus 9 means I'm going to go up here to 9 and put a dot. And normally that's going to be a parabola opening up. But I only can graph for values bigger than 0. So I'm not going to graph the left side. I'm only going to graph the right side. Which means like if I plugged 1 in there, I would get 10. Right? And it's just going to be the right side of that graph. I think I need more dots now. Not going to fit this all in here. Because if I now do the square root part, it's going to flip over that line and it's going to come down here and be that half of a parabola. But I'm kind of struggling here because let's make this not a very accurate graph anymore and add a bunch of points in over here. Well, I could have done by 2s. That would have been smart, huh? So smart here. I'm going to go by 2s, make sure I label it. At least a couple so I know. And again, I know a square root is half of a parabolic side. But if you didn't know that, and you know all you got to do is switch the points, you know if this is the point 0, 9, then at the point 9, 0, I'm going to have a spot on my inverse. And if this is the point, and that's supposed to be over now because it's going by 2's, but that's the point 110, then at the point 10, 1, I'm going to have that same graph because I'm flipping it down that line. Questions about that? How can we make it more exciting? How does the unit test make it exciting? Look at the next one. On these directions on your homework, you do not have to graph. I even think the directions say do not graph because we've graphed these already in Unit 3. They're not really that fun to graph. We have to do the asymptotes. We could graph them, but they're just a pain, right? So you don't have to graph these, but they do want you to be able to find the inverse because there's a lot more algebra in it. And I can tell you 100% that this type of graph is on the unit test of, not this graph, this type of problem where you have to find the inverse with the fraction. Why is it harder? Because there's an x in the top and there's an x in the bottom. But if you just do a few of these, every time it's the same. Step 1, I'm going to switch my x's and my y's. So this was my y, I'm going to make that my x now. And this is going to become 2y minus 3 over y plus 4. And then what we have to do is we have to figure out how to get y by itself. And the problem is that there's two y's, and there's a y in the numerator, and there's a y in the denominator. So does anybody have a suggestion of something that we could do to this problem to start making it somewhat better? Nate? To get this out of the bottom, could I multiply both sides by y plus 4? I need to get rid of that fraction, so that's the first step that I need to do. I'm going to distribute on the other side because although it's kind of making it worse, I got to get rid of those parentheses. So I'm going to make that x times y plus 4x equals 2y minus 3. And again, here's the issue. We have a 2y and we have an x times y. I can't put those together. Like you can't add xy plus 2y because one has an x and one doesn't. But well, the problem is if we divide by y, then this is going to be divided by y. You see what I'm saying?
Well, I meant like if you divided the xy.
Oh, okay.
If you divided it by y, then you would get y on one side,
So,
and the 3 would move over to the other side.
So
you would get x plus 4x minus 3 equals y. And then your x is going to go.
but if I divide by y, you have to divide everything by y. You see what I'm saying? Like, I see what you're saying. Because you're like, well, if I divide by y here, that's going to move that y. But you can't just divide this by y. You'd have to divide this by y. This works out nice, but then you have a y over here. So dividing's not really a good idea. But what if we just put our y's on the same side together, even though there's junk with it, and everything without a y on the other side, and see if something jumps out. So what I'm going to suggest is let's move this 2y over here, and let's move this 4x over here, or the other way. All right, so I'm going to subtract 2y to this side, and I'm going to subtract 4x over here, and you're on the right track there. It's just, instead of dividing, we're going to do the nether term that's kind of like dividing. Oh, you're going to get... But then you get this divided by x. So your answer is going to be way uglier than my answer. But we can look at it. I think if we do this, now I have, what, negative 3 minus 4x on this side, and xy minus 2y on this side. You with me to there? Can I take this y out from these now? Instead of dividing it, can I factor y out front? It's like dividing, only it's less messy. Because if I take the y out, I'm now left with x minus 2. And what could I do very easily now to get y by itself? Divide the x minus 2 over. And I end up with my inverse being negative saying your way's wrong, Jake. It just doesn't look as pretty, right?
X2y minus 3 divided by x minus 4.
Right.
So, yeah, embrace the ugly.
Say that again.
2y minus 3 divided by x. The whole thing is minus 4.
Yeah, this is not right because you still have a y in it.
Just keep going.
Right? So that's the problem. You can't have an inverse that still has a y in it. You have to get y all by itself. So this is really the best method. Multiply it over, get your y's together, factor it out, divide it back over. And it'll always end up being another rational function. I gave you a couple on your homework. We'll talk about them on Monday. And again, guarantee that's going to be on your quiz on Tuesday because I know it's on the Unit 4 exam because you know the unit exam is going to give you the harder type of problem. That's the harder type of problem. Make sure you read the directions because you don't have to graph all of these. Um, 45 is the one where you have to kind of flip it over the line. You can just sketch the graph. And 46. And then 48 through 60 is where you're finding the inverse and sketching the graph. They're not bad. Those are not bad ones. 63 and 66, a little bad. And we'll even say you don't have to graph. Do not graph 60, 63, or 66. 51, 54, 57, 57. So that's only 3 you have to graph, okay? If you want graph paper, I can give it to you.